It is recording now. So I'll edit out, all the swearing and everything if we get into that, because we are going to talk about testing today and CI/CD, which can be frustrating. But I think that Athens did a pretty decent job. And part of the whole point of these office hours is two things, actually. It's one, if you have questions, blurt them out or put them in the chat. And if I see something pop up in the chat, I'll just open it up real quick and check out what the question is. And you won't be interrupting me. I'll just, dive into the question, and that might send us down a different path, and that's totally cool. This office hours is for all of us. It's not just for me to blab at you. It's interactive. So if you have questions, if you know the answer to something, if you have a comment, whatever it is, feel free. Just put it in the chat or just blurt it out. So I'm going to share my screen, and I'm going to go into the Athens code base. Can anybody not see this? My VS Code window?
Good for me.
All right. Take that as a yes from everybody then. So I'm going to basically start with the makefile, because this is kind of the entry point to all of the tests that we run. Both running the tests locally, if you're doing like a PR or something, or you're messing around, and also doing the tests through our CI system. So it's kind of both ways. This is going to be sort of the entry point. And you can build the stuff directly, for building, you can literally just copy that. Or if you come down to one of the test targets, like unit tests here, it's all like in a script. So if it's more convenient for you to just run the script, that's totally cool too. But most of us, including me, I usually just run, make test dash unit, and just kind of takes care of all the setup for me. So is anybody not familiar with a makefile before we continue? Okay. All right. So if along the way there's questions on makefiles, I'm totally willing to pause and give you my woefully incomplete knowledge of makefiles, and hopefully someone can chime in if they know more about makefiles too. So with that, we have unit tests and we have end-to-end tests. So in the code base, I'll go into an example of what one of our unit test suites look like. In the past, we've talked about the storage backends for Athens. Those are like all the databases you can set up to have Athens store modules and module metadata. And we have a test suite for the storage backends too. So these are all the plugins that you can set up. And we have one test suite called compliance that is basically the reusable suite of any storage driver. And you basically plug in one of the storage drivers to the test suite, any one of them. And since they're all driven off of a common interface, the tests can basically run through a generic set of tests for any interface you give it. So heading over to tests.go, there's this one function, run tests. You pass it the interface, storage.backend. And then you also pass it this clear backend function. Clear backend is just an empty function you have to pass. It takes care of just tearing everything down at the end of the test. So let's say you're passing in a storage.backend for MongoDB. You also have to pass in a function that takes care of cleaning up MongoDB after all the tests are done. So I'll show in a second how you call run tests from one of the actual storage drivers. But you can kind of see here, you're basically calling clear backend before all the tests to make sure you kind of start out with nothing in the database. And we're using this require.noError. And that's a helper function from this testify dependency. Is anybody familiar with this testify library?
I've used it a little.
Okay. All right, let me dip into the Go docs for this real quick for everybody to kind of be roughly on the same page. Godoc.org. All right. So Testify, Dylan, you might know this. Testify is kind of like an overarching test suite thing. So you can write like Java style, sort of approximately Java style test suites. And we take advantage of that in some places. But a sub package of the test suites is this thing called require. And require is just kind of like helper functions to make sure things are equal, or like we use it to make sure right here to make sure that something does not have an error in it. So in this example, we're making sure that clear backend doesn't return an error. Going back to the Godoc, there's a lot of stuff here. You can make sure something is empty, like approximately empty. I talked about equal. You can make sure that something returns the exact error that you expected. And that list goes on. So I actually really highly recommend checking this out. It will probably save you a bunch of lines of like, if error not equals nil, testing the error, doing that kind of stuff. It's really nice in the test because you can focus a little more heavily on the actual test instead of error checking.
We actually spent a lot of effort writing tests using Ginkgo and Gomega.
Ginkgo.
And I like Testify a lot better because it's simpler, less opinionated, I should say.
Cool. I'm not familiar with Ginkgo. What is that all about?
It's kind of Ruby style. It should structures.
Okay.
And then Gomega is a corresponding assertion library with a K, Ginkgo.
Oh, gotcha. Ginkgo.
There it is.
Nice. Let's go to, let's see. Maybe the website has examples?
Somewhere, yeah. Before I started writing Go, I wrote .NET code for a long time. So this kind of lines up with the XUnit style testing as far as the code you write.
Gotcha.
So it appealed at first and less so over time.
Oh, gotcha. Okay. This looks like, definitely looks like the Rails type of thing. I guess Ruby in general. Oh yeah, Mocha. I remember Mocha vaguely. I never got super deep into the JS world. I just can't handle like keeping all of the different tooling in my head. I guess I'm an old man in that respect or something.
Yeah.
What exactly do you mean, Mark, used in production code? Like, are you meaning like the Testify or the Ginkgo stuff?
The Testify, yeah. So you can do like check not null, all them types of things, precondition checks to avoid all your if not null and so on.
Yeah. So you can't do it with. I don't believe you could do it with Ginkgo, but Dylan, you might know better. And I know you definitely cannot do it with Testify either.
Yeah, I know Testify takes in, basically wraps a testing.t.
Yeah.
Right.
Yeah.
And Ginkgo is kind of the same. You write all this code and then you write a regular Go test that bootstraps your suite that ends up calling all the describes, which call all the nested contexts, which call all the its. So it's kind of the same thing. There's an implied testing.t that gets plumbed through all of this stuff.
Yeah. Like kind of the same over here. You pass it the T, like Dylan, you were saying, here too. So kind of like at the lowest level, when there is an error, you kind of have to, like in production code, you have to percolate it back up. But here you can kind of just like require dot no error kind of just does like a T dot, in this case, a T dot fatal, which just kills the test. So there's a lot of changes in Go regarding error handling that may or may not come in the future to change that. But yeah, at the moment, Ginkgo and this have a way out in the testing world because they can just kill the tests right away. So, Mark, does that answer your question decently?
It does, yeah. Thank you.
Cool. Okay, yeah. So this goes through, there's basically like a test for each functionality that a storage.backend has. So if you weren't around for the office hours on this, storage backend is basically CRUD, create, read, update, delete, for a module. So we've got a bunch of different things that basically test the CRUD workflow. I mean, you can kind of guess what they are. For example, this one makes sure that if you ask for a module that's not in the storage, that you get a not found error. Making sure that there's a delete, making sure that the interface returns true when you ask if a module exists and the module is actually in storage, and so on. So like these tests, there's a bunch in here. But I really like this pattern because we've got a ton of storage interface or storage backend implementations for this interface. And if you go into like the file system one, there's only one test file, fs_test. And then if you go into the test file, there's basically one test function, where you spin up the underlying file system, and then you create the storage, the actual storage implementation for the file system storage. And then you basically just run the tests. So that's compliance is that package I just showed. And this is all the code you really have to write for any storage backend that you end up creating. And it runs through all the tests for the storage backend. So we kind of repeat that pattern elsewhere. But I really like to highlight this one because I didn't write it. I didn't even come up with it. I didn't have almost anything to do with it. But I really like the pattern, and I'm really proud that it exists in Athens, and I think it's really cool. So I'll go into another package that shows a little bit simpler tests. There, let me make this bigger. So we have this thing in the module package, completely unrelated to storage. And this thing is called the go get fetcher. So if we look in here, the go get fetcher is basically a big old struct that deals with calling go mod download behind the scenes when Athens checks in its storage for a specific module that you asked for, and it finds that the module itself is not in storage. So that means that Athens has to go and do a go get call behind the scenes to download the code from upstream somewhere, and then once the go get is finished, then it will store it in storage, and from that point on, anyone else who asks for the module later, Athens will just serve it directly out of storage. So this functionality in here literally ends up calling the go get. Let's see if I can go find where the actual call is made. There you go. So what we're actually calling is go mod download, which is a stripped down version of go get. but this is where it creates the command for it, the os exec.command. We set up some environment stuff, environment variables, and the directory in which the command is run, and so on. We actually run it. We decode the output, which happens to be JSON. And we do a bunch of other stuff here too. We check various different errors that we've seen, and we do a bunch of other stuff here too. So testing this is really different from testing a storage backend, because we actually have to test like a real call to the Go CLI. So here is what one of the tests look like. So like this one's pretty trivial. We're just making sure we can get a new fetcher for GoGet. If we go down to like some of the more interesting stuff, right here is where we actually call fetch, and fetch under the hood is actually calling the Go command. But this ends up being fairly simple because on the back end, fetch takes care of finding the Go binary and setting up the environment and everything. So we just make sure later on that it returns the right version and the right zip file for the module and so on. And that pattern kind of continues down here. And this test suite could be much bigger. Of course, testing could be much better. But the GoGet tests themselves are actually fairly simple. But what makes them simple is these are not the standard library test functions. Because the standard library test functions would just be like func test stuff. And then it would take in a testing.t. So this is what the go test command looks for. But we're not implementing functions that adhere to this signature. And the reason they're not adhering to that signature is because they have a receiver. So they're methods on this module suite. The module suite is a struct that's under all underscore test. So module suite is a struct, and what the struct is doing right here is it is setting up basically a file system inside of which the Go binary can run. So that means the tests can basically focus on making sure like the Go binary can run, but they don't have to worry about setting up like an actual temporary file system somewhere or anything like that. They basically can just deal with making sure that GoGet works, and then they can look at the fake file system, make sure that the right stuff is in the fake file system in the right place. And the fake file system is provided here, a memory mapped file system. So once that is all set up, then we actually call the real test function. So this is an actual Go test compatible function. And the Go test compatible function just calls suite.run, and it passes in the testing.t, which came in here. And then it passes in this whole huge module suite of tests. And the module suite of tests is not just limited to the ones we just saw. There's other ones, like there's one here. Maybe I'm wrong, actually. Yeah, this is actually not module suite tests. This is filter tests, which is another suite of tests. But the suite pattern, this test suite pattern, is kind of repeated all over the code base. There's 2 test suites even just inside of this one package, but there's others around too. So I'm going to pause for a second. That's a little kind of a tiny but high-level overview of how the tests work, how they're actually written in Athens. So I'm going to pause and stop for like if anyone has questions or comments or anything like that.
I was reminded of, not this past year, but 2 years ago at GopherCon, Mitchell Hashimoto did a talk on their testing and how they go about testing interactions with sub-processes. As in, they wouldn't build a test that actually shells out to Go. They would create a fake executable as part of the test that just gets injected into the path, so that they're actually calling an external executable. It's just not the actual one, because then you don't need to have it installed or configured correctly, and there's no other interactions other than the fake external command that they're shelling out to.
Interesting. That could actually be super useful for us.
And instead of having to go set up a sandbox environment and have Go installed and have a real working Go binary, you're just calling Go mod download, and your test just verifies that you called it with the correct parameters under the contracts of the tool.
Do you have like a link to that talk or anything like that?
Let me go look and see. It should be around somewhere. I want to say it was at the 2018 GopherCon.
Cool. Yeah, if you don't have to find it now, but if you have a link to it, like put it up on a GitHub issue later, or DM it to me or whatever, because yeah, that could be super useful for us.
Aaron, I was curious from the make file. From the make file, can you run individual suites?
The make file.
Just go through the whole test suite altogether.
Yeah, the make file does everything all at once.
So there's no way just to run, for example, just the backend suites only if you made a change. It'd have to run through the whole lot.
There is no way from the make file. That's right. Just to run just like the backend stuff. Okay. But I wish I could remember. I think you can run the Go test. Let's just try it out, actually. Just gonna change the size of this window real quick. Something like this, I think, works. Oh yeah, and I messed up my standard library on here, but I believe this works. If you were to do Go test and then the package name, I think this will let you run the subtests basically just inside of the storage directory or wherever else.
Cool. Okay.
So try it out. Sorry that I was trying to install Swift on my machine, and Swift messes up all the C standard library stuff, and here we are.
There's something ironic about a Microsoft guy writing Go code on a Mac and trying to install Swift.
Yeah. A little interesting, yeah.
I posted the YouTube link to that Mitchell Hashimoto talk.
Awesome.
In chat. Awesome.
Yeah, I'll leave it up on my browser, and I'll submit an issue for it to Athens.
It was a very interesting take on how to go about testing your code that shells out to other programs.
Yeah, because that's kind of a hard problem. I don't think we've really solved the problem that well. So yeah.
and I think he even goes into like Linux doesn't care. It just needs to be something called Go, and it could be as simple as a shell script.
Yeah. Yeah.
Leading on to that same question, I was wondering, is there any issues with versioning of Go, or any issues that may come up soon of versions of Go, which you therefore won't be able to test this way?
Yeah, so it did affect our tests. So we had support for Go 1.11, and Go 1.11 calculated checksums differently than 1.12 and later. So we had tests that assumed 1.11, and then we had tests that assumed 1.12, and the tests never failed because they never compared the checksums from 1.11 to the checksums from 1.12. So when people upgraded, they saw failures, which sucked.
We actually had a few of those.
Yeah, sorry. But now, so that was one example. And in fact, like the thing that pops into my mind right now, is what you said, Dylan. If we had like maybe some kind of a test executable for Go, we could maybe have two, like one that was 1.11 and one that was 1.12, and then we could compare them or something. That would be good. But yeah, I mean, Mark, we had that issue, and that was a big one, and it was due to how the backing Go binary changed, and how that kind of like cascaded down, and then it affected Athens. And since other people's Go binaries depend on Athens, and Athens depends on the Go binary itself, there's this like inception thing going on, and that caused some rough patches in sort of the early days of modules when it's like no one knew what was going on, including us. And then this thing broke, and we were like, "Oh God, what did we do?" That one is burned into my memory for a while now. So yeah. Yeah, so I guess I'll stop there with respect to like how the tests are written, and I'll dive in a little bit to how to run them, and then like how the CI works. If that's cool with people, unless you want me to dive in somewhere else.
Oh no, that's cool with me.
Cool. All right. So I talked about the make file. Let me just start with running one of these targets. So test unit doesn't work because of this. But luckily, we wrote all the tests so you can run them natively, but you can also run them in Docker. And we do the native way because sometimes you don't want to run Docker. But we do them in Docker because that helps, for me at least, and for a lot of the other folks who do like heavy duty PRs, it helps to run them in Docker because you get this isolated environment that is always the same. So you don't have to set up too much stuff on your machine locally. So let me just run the unit tests inside of Docker. So I'm just going to do it real quick, and I'll show what it looks like. So a couple things to note here. We're actually using Docker Compose, which is kind of a system to run a bunch of different Docker containers in tandem and kind of define how they're related. I'll show what that looks like in a second. Part of the Docker system is we build a Docker image that has the tests in it, and then we run the image. We run this command specifically using that image. And that command goes and it starts downloading dependencies. This is all of the Athens dependencies. And actually, if someone is looking for some PRs to submit, one of the PRs, and I just noticed this today, could be that right now, these downloads, I think, are happening directly from version control. But I think a better way to do it would be to make sure that they happen from one of the hosted Go proxies, like proxy.golang.org or one of the other ones. Probably proxy.golang.org is best. That would speed up these tests probably a lot, but it would also make them a lot more reliable. So yeah, if you're interested in that, go for it. If you want help getting started, just ping me. I'm happy to help. So I'm scrolling, and finally we've downloaded everything and the tests start. We measure code coverage on some of the tests. Sometimes it's terrible, but I believe at least that I remember us focusing a bunch on making sure that coverage was good on the storage. And it looks pretty good, like here, Mongo, S3. One of the downsides, though, is that for some of these, we see 0, memory as 0. And that is because these don't really have many test files. is they're going out and using that common test file, or sorry, the common compliance test package. So we lose out on the coverage statistics that way. So Mark is asking, you could run using Docker. Yes, we could. We don't, but we could. And that would be another good place to contribute if you're interested. It would be fairly straightforward. You could run, I'll show how you could do this actually with Docker Compose. But yeah, you could run the same exact tests concurrently, one with Go 1.11 and one with Go 1.12. And now that there's 13, 1.13, and so on and so forth. And you could run them approximately concurrently. That could scale up and up and up until, you know, someone's computer explodes because you're running a million tests. But we'll cross that bridge when we come to it. And Soumya, that would be great. If you want to go for that issue, please do. Just, you know, if you get to it, submit a PR. Let us know when the PR is up, and we can all go and check it out and review it, and we'll get it into master. That would be amazing. And Mark, if you want to tackle the, you know, multiple Go versions thing, same deal. If you're into it, just go ping if you want help. Otherwise, just go do it and be super happy to review it. So going back to the tests, looks like they all ran. And now there's all this other output, like there was output at the beginning, creating the container, but there's also this stuff like creating a network, attaching to this container name. And then at the bottom, we've got some cleanup, stopping Mongo, stopping Minio, and then stopping this unit container as well, and then removing a network. So this is all Docker Compose stuff going on. So I'm going to go over to our Docker Compose file. And because YAML is the language now of the cloud, I guess, this is a YAML file that defines our entire testing environment. So, and our dev environments actually too. So I'm going to kind of hand wave over dev for 1 second. And I'm going to go down to test unit. So this is actually what we run when I just ran make test, what did I run? Make test dash unit dash Docker. So it ran this. It ran Docker Compose run this. So Docker Compose lets you build a container, build an image. So I built it from this dockerfile.test file. And then it says, after the image is built, run the container with this command. So I will go check out dockerfile.test, and then I will go check out this script. And I have OCD, so I'm going to close a bunch of tabs so I don't go crazy.
I know how you feel. I'm one that can't have more than about 7 or 8 tabs open at once. I have to start closing things.
I'm glad someone can empathize. So yeah, here's dockerfile.test. It's pretty simple. Yeah, and Mark, like this would be where like you could create another Docker file for 1.11, for example. You would just change the tag. But yeah, it's simple. We basically copy all of everything into /Athens/tests. And then when the image is run, we basically are already in the working directory. But the magic is basically in testunit.sh. Oops. So testunit.sh sets up storage. So Minio storage and Mongo storage. And this is important because we're basically going to be doing unit tests with Athens configured to talk to Minio, which is sort of like an on-prem S3, and also Athens configured to talk to Mongo. So that's 2 storage backends being tested. these are unit tests, so we're not going to test everything, all the backends exhaustively. But we happen to be able to test these locally in Docker containers in our unit tests. So we went for it, and we just figured, Docker Compose lets us thread together a bunch of different containers, so why not? So we set that stuff up. These are just standard Linux environment variables, which Athens can read. And then we just do our go test. So we do some code coverage, and we just run everything. Oh, and we run it with the race detector on. But yeah, we run the tests on everything, and we rely basically on having our environment be immutable and sort of hermetically sealed using Docker. So basically, this is the unit test Docker service, Docker Compose service. If we go down here, though, there's these depends on Mongo and depends on Minio. So if we keep heading down here, we have, where is it? Yeah, so we've got Mongo and Minio here. I kind of mentioned it just now a couple seconds ago, but basically Mongo and Minio are just running MongoDB and Minio containers. So like Mongo is like 4 lines. It's just like, this is the standard Docker Hub Mongo 3.7.9 container. And we're just mapping the default Mongo port to the same Mongo port on the Docker Compose sort of not mesh network, the Docker Compose loopback network. Same thing with Minio, same exact deal, except we're setting some access keys and secret keys because Athens expects to use keys to connect to Minio. So that's kind of it in terms of the YAML we have to write. There's a bunch here, and the rest of this stuff is pretty much used for integration or end-to-end tests is what we call them. But for unit tests, when you do a Docker Compose command, it will figure out from the target that you gave it, it'll figure out all the other stuff it has to start up, which is Mongo and Minio. And then it will create volumes for them if you specify. So I scrolled down here. These are volumes that we need. These are disk volumes that we need for end-to-end tests. So we don't need anything for unit tests. But it'll also automatically create networks for you. So networks are kind of like I said, it's a group of containers that are created on a single network in a single IP port space. So by default, Docker Compose just creates a default network, and all of the services that we need are on that default network. And what that means is that when Athens runs, it can expect to find Mongo on localhost 27017, and same thing for Minio on 9001. And if you go up here, you can see there's Minio. Actually, that's broken. There's another bug if someone wants to look into that. Why are the tests succeeding when that's wrong? That would be another good one. But then I believe, yeah, we're using Mongo by default. So 27017 is working here.
I think you're looking at the wrong one. It was 9001, I think, exported.
Oh, did I do that? Yeah, good point. Good call. So yeah, Minio 9000. I wonder why we did that. We just didn't keep it the same, but there it is. So actually another thing I noticed to your point, Mark, is that we're setting our configuration to just use Mongo. We're not using Minio. So there could, in theory, be another test unit service, call it like test unit Minio or something, that sets this environment variable to be Minio. So another thing that if someone wants to pick that up, that's totally welcome. If no one wants to pick it up, that's cool too. Eventually it'll get done. So going back to the make file, that's basically test unit Docker. So this command to sort of decode this, Docker compose is the Docker compose binary, fairly straightforward. -p is a project name. So that kind of puts all of these things under one umbrella. Any volumes that we create, any networks that we create, the actual service that we want to run, and all of its dependencies, they all go under one project name, which then allows us to do a Docker compose down with the project name. And that just tells Docker compose to delete everything that was related. So scrolling to the right here, we've got a up command, and we're saying if test unit fails, then fail the actual Docker compose run. That's obviously important for, especially for CI. But also if you're running a shell, you want to see if it succeeded or failed by the exit code. And then this one is just build test unit. That's the root of the services, and that cascades down to all of its dependencies. So yeah, that is the unit tests. End-to-end tests are actually more setup, but at the current moment, a lot less actually being tested. So let me run E2E Docker, and I actually think that my machine's messed up. So this might actually fail. So kind of the same deal, Docker compose up. Oops, let me go back down up here. Oh boy. So Docker compose up, Athens E2E is the project name, and we're running the test E2E thing service. We're building another container, another image, then we run the container. We are running test E2E.sh. And going down, I think, yeah, I'm missing a dependency. I think this might be some fallout from we're not copying the right dependencies into the end-to-end test container. So yet another thing, I don't want to sound like I'm trying to pawn all the bugs off on people. If someone's interested in looking into this, awesome. If not, I'll probably go and check this one out after a few days if no one wants to pick it up. So what this is actually trying to do is it's trying to start up in Athens, and then it's trying to check this endpoint, readyz. So readyz is basically a health check. Some systems, some cloud systems like Kubernetes or AWS load balancers, elastic load balancers, you can tell systems like that to constantly do an HTTP request to this endpoint. And this endpoint will respond with a HTTP 200 OK. And that'll be an indication to the load balancer or whatever system it is that, hey, Athens is still healthy and you should still route requests to it. So I believe since Athens actually never started up, this is going to just go on forever. So this is what it looks like when tests fail. And in a CI system, basically CI would let this run for a little bit, a timeout would happen, and then CI would fail. So you've seen a test succeed and a test fail. So I give you the whole perspective. So let's check out the E2E service. So we're using the same Docker file, which means we're building the same image. And again, the Docker file is super simple. It just has all the code in it. And then now we're doing a test E2E. So test E2E sets up a bunch of environment variables. And basically, we go down to here. Go. We set up a Go proxy. We check to see if our catalog endpoint returns the stuff we expect. And the stuff we expect is checked out above. Where is that? Somewhere around here. We're actually checking out code. Yeah. So we're checking out a dummy Git repo. we're basically pushing the code from that Git repo into some storage, and then we're making sure that Athens can recognize it. That stuff was supposed to happen after those checks to ready Z. That stuff was up here. Where was it? Right here. So after, if we had gotten past this, then we would have started testing out Athens catalog endpoint. And the idea here is eventually to expand this script and start actually testing out, like, what does it look like for a real Go command to do a real Go get or Go run or Go whatever against a real locally running Athens server, and make sure that all that stuff actually works with a variety of different storage backends. So that is sort of most of the test infrastructure. I'm going to pause. We've got about 15 minutes left. So I will go into a little bit of the CI/CD stuff, but I'm going to pause now for any questions, comments, anything else. Shout them out if you've got them.
Do the unit tests set up Mongo for you as well? The ones not running in Docker?
The ones not running in Docker, I believe, this is off memory. Yeah, I think that you have to have run this make all deps. So you have to have run these or this target, and that sets up Mongo, Minier, and Jaeger. Jaeger is for distributed tracing. And after you've run that, then you can run make test unit.
We do something very similar to that using Docker Compose for our local testing to run Postgres and Jaeger and Elasticsearch. Basically export it at localhost at their standard ports so that we can just Docker Compose up, and we call it like platform deps. And it's all of our external services that our actual code depends on.
So we're not crazy. Someone else does it too. Do you have this in your test suites, this sleep as well?
I do not.
Okay. So I wonder, I remember on some systems, like if you've got a slow internet connection, sometimes like Minio will take a while to download, but Mongo and Jaeger, for example, will not. So Minio will be the last thing to come up, and it won't be quite ready to serve after all deps returns. But I think that's why we had to put this sleep in here.
Yeah, I can see that happening. It hasn't come up for us because we have basically everyone, when they come in, before you start working, just Docker Compose start on the whole thing. We don't up and down because we want to preserve the Postgres data between runs and reboots. So we do stop and start.
I see. Okay. It's good to know.
But yeah, we do something very similar to that.
Cool. Okay. So yeah, Mark, there is, I know there's a document somewhere. I think it is in GitHub, not on the docs.gomods.io. It's linked from docs.gomods.io and from the README. And it is, I believe, a file called, let me just go and find it. It lays out how to do this. Yes, development. Run the proxy. Yeah, here we go. Services that it needs. It kind of talks about like you don't need actual S3 access to do unit testing. But where is make all deps? Yeah. So like this is how it talks about doing it natively. This is how you can do like the native end-to-end tests. But somewhere in here, yeah, this is how like it tells you how to do it with Docker. So I would say this is sort of like a starting point. And Mark, if you do try these out, I would love to hear what works, what doesn't work, because I haven't personally done the native on the machine stuff in like a while, I think in a month or so. So if something comes up, I would totally love to hear about it. I can help you fix it. I can push a fix up to the repo too. So let me go back, and got like 10 minutes left. Let me talk a little bit about CI/CD. So we use basically two primary CI/CD systems. We use Drone Cloud and AppVeyor. So Drone is a Linux CI/CD testing system. Let me go to these, drone.io. So it's a hosted system for CI/CD, just like, you know, Travis CI or Circle CI or something like that. And then the other one is AppVeyor. So AppVeyor is basically Drone, but we take advantage of the Windows integration. So we test Athens on Linux, and the same tests approximately on Windows as well. You can kind of see it in PRs. Like, I'll just go to a random PR. If we go down here, there's a bunch of other stuff like Circle CI. Circle CI runs basically to do some like tangential stuff. You can see like it does linting on the Kubernetes Helm charts. It does linting on like test unit.sh. And that's kind of legacy. Like, we still should do these, but we used to use Circle CI for everything. We just didn't move these over to Drone. So we do have Circle CI stuff, but the real stuff is happening in AppVeyor and Drone. So like going over to one of the Drone thingy, going to build. This is literally test unit and test E to E. Just like scroll down and basically see all this stuff. So I'm guessing since this failed, there's a failed test somewhere in here. Does Athens have to set up scripts that lint Helm charts, or is that built in a Circle? That is not built in a Circle. Top of my head, I couldn't tell you, but I know we have a script somewhere in here, probably under scripts. That would make sense. That does linting on the Helm charts and pushes them up to a Helm chart repository. So this looks like it definitely pushes up to a Helm chart repository. And I don't know if it lints it in this place. I don't see any linting here, but I know that we do some kind of linting, because if you make a change to the Helm chart and you don't update, if you don't increase the chart version, the CI fails. So there's somewhere in these scripts that does that as well. So yeah, there's a bunch of Helm stuff that someone submitted, and they're really smart and they know everything about Helm. And I'm very grateful for them, because I don't think I know 1/1,000,000th about Helm that person does. His name is Remus. So if you ever see Remus on the Gopher Slack anywhere, and you need some Helm help, ask him. He's a brilliant Helm person. So that is Drone. Let's check out AppVeyor. So AppVeyor, you kind of see some similar output, finding, downloading. And we run only the unit tests, I think, in AppVeyor. I think we may run end to end. I can't remember where we stand on that. We used to run end to end, but now I think we might not. This failed, so the unit test failed, and if there was a next step, it obviously wouldn't go there. But yeah, this is the same exact script running on Windows as it was running before and drone on Linux. And we do that primarily because, actually, Dylan, kind of your point, we run this primarily to test the Go command on Windows and on Linux. So I suppose like end-to-end tests might actually use the Go command, and then we could use the HashiCorp like fake Go command for unit tests.
Yeah, I would think the end-to-end would be doing an actual integration and call a real tool, but for code level unit testing, you don't want to go reach out across the internet to go do an actual go get. You're just verifying that you're calling the thing correctly.
Yeah, exactly. So that is a place that we should go. So another opportunity if someone wants to go look at that and fix it or change it, or if you've got better ideas on how to do that split between unit and end-to-end, we are all ears. None of us are by far testing experts who have written tests in Athens before. So new ideas, new voices are totally welcome. So last thing, basically this is what a drone file looks like. It's just like a pipeline of Docker commands. It looks kind of similar, at least to me, it looks kind of similar to the Docker compose file. We just keep going. We do a build. We check the Go format tool. We do a Go vet. And these are actually like almost exactly the same commands, like here, for example, almost the same commands as what the makefile runs. Some end-to-end stuff. And in here, we test like Google Cloud Storage. We test real cloud-based services for our storage backends. There's a PR out there to add Azure Blob support. And I think we have S3 support somewhere. I don't remember off the top of my head, but somewhere in here, I think we do S3, not just Minio, but also real S3. That may still be in a PR, so I can't quite remember. So yeah, 3 minutes left. I'm just going to stop there, and I'll stay as long as people want if there's questions or comments or anything like that. Was this a whirlwind tour? Did I go fast, slow? What do people think?
It was good for me. I'm gonna have to duck out in a few minutes. It's quitting time here.
Nice. What do people want to talk about next week? Any ideas? We can do. I can pick something too if no one has ideas. All right. I will think over the next few days, and if anyone else has ideas for something that they want to talk about, just honestly, just ping me, and we'll get to it. We'll talk about it next week. Mark, there is a backlog of recordings. Let me find it. It's on YouTube. I'm going to find the playlist and I'll put it in the Athens channel. And yeah, what's your Slack name so I can CC you? Or Mark, you can just DM me. This is my Slack name. So I'll put it in the main Athens channel, but if you don't see it or anything, then DM me and I'll just send it over to you. Cool? All right, everybody. I will get this recording up to YouTube shortly. Just going to wait for it to upload, which takes forever for some reason. And we'll have this up, and then I will see you next week. See you, everybody.